So in this lecture, we discuss about the context-free languages and its properties. In theory of computing, context-free languages plays a prominent role, and the major contribution of these context-free languages and the related grammars are in the form of a parser. So in this discussion, we'll start with a definition. Usually the grammars, languages, in theory of computing, we have the concepts called generating device and recognizing device. So generating devices are the ones which generates words, and this generation is done with the help of an abstract device called grammars. In recognizing the recognizing devices are called machines such as finite automaton, push down automaton, Turing machine, those things, and these machines are called recognizing devices. Reckoning devices does the work. Given a word, it will say either this word is acceptable or not. So they are called the recognizers. And in another sense, the grammars are called generators. So now, why do we want to have this discussion on generating devices and recognizing devices? Everything is related to the concept called computation. So in theory of computation, as as being briefed by many of the authors, theory of computation is the science of the computation. What is happening in the background of the computation? That science is brought about by the theory of computation. In fact, a computation is a physical process. You are given some inputs and you do a logical process, finite number of logical steps, and have an output. This process is called a computation. In another sense, a physical process, the purpose of which is the abstract manipulation of the abstract objects. Abstract objects may be anything, and this manipulation of abstract objects will be by in the sense of a logical operators, and every object will be defined by its formal properties. So for example, if I want to operate, if my abstract objects can be matrices also. So if I take a matrix, I can perform, I can manipulate the abstract objects with the logical operations and arrive at an output. So this process is called a computation. And what do you mean by a computational model, or in another sense, a computer? A model which does the computation is called a computer. So Turing machine is itself a computer. Maybe Turing machine can also be called as an abstract paper pencil computer. And the language accepted by the Turing machine, language, because as told already, Turing machines are called, or or recognizing devices. So Turing machine recognizes a language, a class of language called recursively enumerable languages. So a device which generates recursively enumerable language can be called as a computer. So now, with this introduction, we have come to understood what is a computation. In simple sense, you have some inputs, perform some logical operations, and have an output. The whole process is called a computation. And this computation is achieved by two types of models called generating models, recognizing models. So these grammars come under the heading generating devices. So now, for example, we have this phrases wash the face and face the wash. And there is a difference between the first sentence and the second sentence. The first sentence gives a meaning just wash the face, which has a normal literal meaning as in English. Face the wash, though it gives a totally different meaning. That is, face the wash implies that you will face your destroyment or you will face your destruction. That is the thing. But see the things in both the sentences, there are three words wash the face, but the position have got changed in the two. So since there is a change in meaning when the words are transpositioned, this the language which supports these words are not context free. So context free means wherever you place Contextually, it is independent. Wherever you place a word in in different position, the meaning should not change. So this is an example for of a language which is not context free. So it's needless to say that English language is not a context free language. So now, as mentioned earlier, here we are going to discuss about the context free languages. Okay, what is so we'll have two terminologies: context free languages, context free grammars. In fact, what is a grammar? Grammar is a rules and regulations to generate the words of a language. So, intermittently, we'll be using the phrase context free grammar as well as the context free languages. So, before starting the actual definition and other terminologies, will have a motivation. What is the purpose of, one main motivation is this grammar is a generating device and it is used to do certain computation. Now, we'll trace back the history a little bit. So, in 1959, Noam Chomsky tried to give a mathematical definition for a grammar. That is, can we capture the grammar of a language in the sense of mathematics? Of course, here it is needless to, here it's needless to say that if you are able to capture a grammar in the sense of mathematics, it will have a very clear cut definition. The languages will be will be free from all the ambiguities. So, in fact, that is the major drawback of the languages which we call as the natural languages, because the same word, depending upon the usage, they give a different meaning. For example, in English, if I use the term Mr. X has kicked the bucket, the literal meaning is different, but actually the usage is, the meaning conveyed by this Mr. X kicked the bucket is totally different. Though, if you go literally by the, if you go, if you capture the meaning of Mr. X kicked the bucket, you will say that Mr. X has kicked the bucket which was put in front of him, but that is not the case. So this is the, here the ambiguity of the language comes into the picture. So his Noam Chomsky's main intention is to capture the grammar in the sense of mathematics. So for that, so here, for if you want to express the grammar in the sense of mathematical terminologies, grammar should be formally defined. So that was his main intention. So in that process, he defined four types of grammar, namely type 0 grammar. It's also called recursively enumerable grammar. Type 1 grammar, context sensitive grammar. Type 2 grammar, context free grammar. And type 3 called regular grammar. Now, when Chomsky was developing all this thing, at the time Algol was, the programming language Algol came into the picture, and as it goes without saying that Algol is a block structured language, and uh, the people were in the process of developing a grammar to describe syntactically correct program, to validate the programs which are syntactically correct. That was the process which was going parallelly, and that process for the Algol was called as BNS, Buck's normal form, or in short BNF. So the Chomsky's development, in Chomsky's context-free grammar and the BNF were finally found to be one and the same later. So with this type of motivation, we get into some more information about the grammars. So the grammar for a programming language, it is used to validate syntactically correct sentences, correct statements of the language. And this concept of grammar help the people to design the compiler for that particular programming languages. And most compilers and interpreters for programming language contain a component called parser. So there are plenty of methods available now for the construction of the parser from the grammars. And in one sense, regular languages will regular grammars, the corresponding for every for every language we have a grammar at the background. So the so-called regular languages generated by the regular grammar functions in this way. The words are produced from left to right, but in CFG, which is our focus of discussion, context-free grammar, have evolved from the center. That is a more complex pattern of generation. It's not necessarily from left to right or left to or right to left. So this discussion, so in that sense, context-free grammars are slightly powerful than the regular grammars. So for example, so one grammar is described here where S refers the sentence, NP stands for noun phrase, and VP stands for verb phrase, article. And so now I'm in all these things we have one line by line. Each line is called a production, and the one which is on the left hand side, yes. So from sentence produces NP1 VP. So this then what is this NP1? NP1 is again is a product of a combination of article and the noun. The second production, NP1 produces article noun 1. Article produces the noun 1 produces man. Like this, this is the way we describe the rules and regulations. With this, see here, a sentence will be generated by repeated application of all these productions. So for example, S produces NP1 VP. There is a production, first production, see that S, we'll call this as productions or rules of the grammar in whatever way you feel it. So by repeatedly applying all these productions, we form the sentences such as Venice is a beautiful city, or the man ate the fruit. So now S produces NP1 VP. Then NP1 is replaced by article noun because there is a production call. See here in the second rule says that NP1 can be replaced by article and noun 1. And article again in the third thing, article is replaced by the here. See here, article, the third rule says that article can be replaced by the here. And then noun 1 is replaced by man. The fourth rule states that noun 1 can be replaced by the man. And then VP, verb phrase, there is a production. Verb phrase is replaced by verb and NP2. So here we see that. Then verb, there is a production. Sixth rule, verb replaces ate. So now, so far we have the man ate NP2. So NP2, there is a production here. NP2 is replaced by the last but one rule, article and noun 2. So the man ate, article and noun 2. Then article is replaced by another application of the rule. Art is replaced by the, and noun 2. There is a production here. Noun 2 is the last rule. Noun 2 produces fruit.